course, I did that still. Okay, so what? Let's focus on this piece. So this topic is on figuring out what function, okay? So lesson, okay, I'm not gonna even write down lesson number. Write possible rational function. In the form y equals to p of x over q of x. Okay. So in the past, what we've done is we have given an equation, a function, and then we were supposed to figure out the vertical asymptote, horizontal asymptote, whole, x-intercept, y-intercept, and then we're supposed to graph it, right? Now what we're gonna do is we're gonna go a little bit backwards and see if we can create a possible rational function, okay? So I have a few examples in here. In fact, I have 4. I mean, we could probably create more if we need more, but so far we only got 4. So let's take a look at example 1. So here's what we're gonna do. I'm gonna give you some clues and then write the possible function. So here it is. The asymptote at x equals to 2 and y equals to -3. We'll call it asymptotes. Okay. Write a possible Okay. I'll give you a moment to write that down. Now, if you're already thinking about that, you got 2 clues in here. You got an asymptote at x equals to 2. Is that a vertical or a horizontal asymptote? Vertical asymptote at 2 and a horizontal asymptote at -3. Okay, so can we picture that in our brain? Let's see here. Okay, vertical asymptote at 2. So this is your x-axis, y-axis. Vertical asymptote. Okay, x equals to 2. And then horizontal asymptote at -3. One, two, -3. Those are the only things that we have, or the only things that we know. So, what could be a possible thing? Possible rational function. Okay, let's start with this. How can we have a vertical asymptote at -2? How can we get a vertical asymptote at -2? X minus 2, where does the x minus 2 go?
There's a Q.
Denominator, right? Okay, so you know that one clue, because this is x equals to 2, then that means you have something x minus 2 equals to 0 in the denominator, right? So that's great. X minus 2 in the denominator. Good. Okay, so now what about this? Leave that alone. What about this piece? How can we have a horizontal asymptote at y equals to negative 3? When do we get that?
Well, you need to have a leading coefficient of 3, I think. That we have a leading coefficient of
Mm-hmm. So you're going to have a negative 3 coefficient where?
like on the top.
The numerator. Mm-hmm. Negative 3x. Okay. Is everybody okay with this? So if we have a horizontal asymptote at negative 3, that means that shows us that the degree of p of x has to be less, equal, or greater? Equal to the degree of q of x. Do they have the same degree? If they have the same degree, which they are at 1, what did we do? We said the leading coefficient of the numerator is a over b. Okay? So the leading coefficient of the numerator is negative 3. The leading coefficient of this is 1. Good. So this is a possible solution. Okay? Now, is there any other possible function that fits this description? Is there any other function besides this? Hmm? Okay, well, they didn't say any whole, so there's no whole. Okay, so there might be no cancellation. So that's a good question. Yeah.
It can be kind of like solutions because you can, after minus 3x can be and
Mm-hmm. Yeah, okay, certainly. Or here's another possibility. Negative 3x, give me a number, plus 1. Does that still fit in our situation? Our vertical asymptote will still be at 2, correct? Yes? And our horizontal asymptote will still be negative 3 over 1. Okay, so there's probably more than one solution. That's why it's called possible. Just one possible thing. Okay? Okay.
So one solution can be enough. Okay.
Yeah, yeah.
Can be negative 1 over 4x.
Say, okay, come again. Tell me.
Negative 1.
Negative 12. I'm going to write it down over here. Negative 12 over 4. Mm-hmm. Minus 2. Okay. Will this give us a vertical asymptote at x equals to 2? So it's going to give us 4x minus 2 cannot equal to 0. So 4x equals to 2 divided by 4. So that's going to give us a half. so no, it doesn't work. Okay. That's a good one. And you're thinking about it. That's great.
Well, we ever have questions that ask us to pick more than two possible, or more than one possible function.
Yeah, there's this one here is a more possible one. Yeah. Okay, let's try another one. This is pretty neat, isn't it?
Maybe it's kind of the two. Eight.
Mm-hmm. Yeah. Let's write that down. Because you can go y equals to, say that again, negative 12x over 4x minus 8. Yeah. That works. Would that work? Is our denominator going to be still going to give us a vertical asymptote at 2? Yeah. And if we divide these two, is that going to give us 3? Negative 3?
Is there
Awesome.
a finite amount of equations that you
No,
could
it's
actually find?
probably lots. Yeah. It's lots because you can just change this many times, like 0.1, 0.7, right?
Like, given
Mm-hmm.
the range of numbers, it's probably an infinite number of possibilities.
Mhm. Yeah. So if this happens to be on a test or on an assignment, then there's no one answer key. This is going to be horrible for me marking it, right? So I got to check everything. Hopefully you guys don't come up with like complex stuff. Okay, good. Awesome. Okay, number 2, example 2. Here's a clue. Vertical asymptote at x equals to plus minus 2 and horizontal asymptote at y equals to 0. Okay. So how can we have a vertical asymptote at x plus or minus 2 first?
Denominator.
Because this one kind of tells us what the denominator is going to be like, right? It's going to be, okay. I'm just going to go like this. X plus 2, x minus 2, or we can say x squared minus 4, right? Okay. We'll fix that later. Okay, good. So we figured that out. That's awesome. What would be the possible one? That the horizontal asymptote at y equals 0. When do we get y equals to 0?
When Q of x is less than Q of x.
So the horizontal asymptote happens y equals to 0 if the degree of p of x is less than the degree of q of x. Okay. What could be a possible numerator then? Could be 3x, right? Because the degree of this is 1 and the degree of the denominator is 2. Yeah. What could be the possibility? This is lots.
Could be 6 like any number, standing number to 0 degree in the numerator
Okay, what's that, I think?
has 6.
6. Okay. Yeah. Anything else? Lots. Is that okay? Yeah. The degree of the numerator is less than. So there's infinitely many possibilities here. Okay, let's take a look at example number 3. Let's add in a Okay, this is a little bit different. There's a hole or point of discontinuity at -4, -2, and then the x-intercept at -1. So that really means that there's no horizontal asymptote, no vertical asymptote given in here. There's many possibilities here too. So let's take a look at the hole. So how can we figure out a hole on
X plus 4,
x plus 4?
but it has to cancel.
But it has to cancel, right? So how do we know it has to cancel? That means there's going to be an x plus 4 on the numerator, and there's an x plus 4 in the denominator. Okay, so that. Now let's take a look at this one. X-intercept at -1. How do we figure out the x-intercept again? Okay, so x-intercept at -1.
Plus 1.
X plus 1, so it's going to be x plus 1. Where would the x plus 1 going to be? On the top.
So we could just make it linear.
Yeah, to make it, you're thinking about, okay, x-intercept at -1. I'm going to put it on top and then I'll explain why. What did I say? X plus 1. Okay, so when we look at the x-intercept, what do we normally do? We set y equals to 0. So this is going to be, okay, I'm going to put this back later. I'm going to put 0 here for now. And if I cross multiply, and if I cancel these, and or cross multiply, you're going to end up with 0 equals to x minus x plus 1. Bring this to the other side, it's x equals to -1. Okay? So this one will help us determine the x-intercept on top. Is that okay? Then you'll end up with the linear in this case. I think I'm going to stop right there. I'm not going to, because the next example would be pretty similar to example 3.
I was just gonna ask, how do you find the y value
Which one?
of the hole, like the -2?
-2. Okay. So this is your x and this is your y. Okay, let's see. -2 for y. -2 for y, because this will eventually cancel, right? And this is going to be x plus 1. It's going to give us, I think we're going to need an a value in here. Yeah, because it's not going to balance with our -2 there. Okay, so we're going to have an a value in here for that. An a, okay. Let's grab this. X-intercept at -1, -4, -2, 1, 2, 3, 4, -2. This is that one. So now we're going to work backwards and try to figure out this equation of the line. Okay. The x minus 4 will cancel. We're left with this equation of the line. -4, -2. So go 1, 2. So slope is up to 1, 2, 3, right? 3. So it should be 2/3. So that means the A value here, this one has to be 2/3 to make it work with this. Okay, so cross it off. So y is equals to 2/3 x plus 4, x plus 1, x plus 4. To make it work for this particular hole.
How do you get the value?
What's that?
How do you?
How did I get the value of A? So like, we figured out the slope here. So rise over run from this point of discontinuity to this, because we are going to end up with just the equation, the line, right? After you got the x-intercept and then this pretty much a hole. So up to right 3, so 2/3. Let's see. This cancels. So if this is -4, plus 1, it's going to be, should be, no, I'm not going to use this one. -4, -2. Got to find out the y-intercept here. Oh yeah, it works. So yeah, it does. Okay, so it's like, oh, okay, yeah, it does, because this is going to give us -1. So yeah, this one has to make it, we have to make it 2/3 to balance it out. Oh yeah, so this x-intercept, yeah, would still be x plus 1 from this x plus 1. Because we factor out.
Minus, like for 1%.
Minus,
2.
oh, -2? Oh, that's from this point of discontinuity. Because the x is -4, the y is -2. So I'm using this point, basically got 2 points in here and this point to figure out the slope of this line. The slope is 2/3, positive 2/3. Yeah. No?
Because then you put, when you plug the minus of equation, where it's like, 12/3 minus 4 plus 3, and then you place y to -2.
Yeah, I'm testing if this actually works, this 2/3. I'm testing if this works, this 2/3.
Then you
It should.
replace x minus 4.
Yeah.
Y is minus 6.
So the x is -4, and then the y is -2, and they balance -2 equals to -2, so that means it's a right equation.
But for me, that's just like, does the 2/3 cancel out, or I don't understand.
Yeah, the 2/3 won't cancel out because it was factored out. So whatever the numerator is, I'm going to fix that one. So this is what it would look like if we were to simplify that further. So 2 times x plus 4 times x plus 1. And then the denominator is just 3 times x plus 4. Yeah. The x plus 4 cancels still. That's your whole. Your y-intercept would still be x plus 1. Yeah. Okay. Is that good? This. And this one is a very specific answer, very specific equation. Okay. So that concludes some questions. I just want to point out to you here, the thing that we did today on this particular handout, this is not for hand-in, although there's still some stuff in here that I think a lot of people would benefit from. So the question number 1, basically find a possible equation. Okay, so just like what we've been doing. Okay, so A, B, C, and D, and do work with another person. Do talk it out. Number 2, identify any asymptotes, points of discontinuity, and intercepts here. This is something that we've done before. So just to kind of brush up our skills on figuring out the asymptotes, any holes, and intercepts. Okay, so that's that. Should be pretty straightforward. Number 3, okay. Identify the x-intercepts and the equations of any vertical and horizontal asymptote for this. Okay, now there's no specific number. It's A, B, C, and D. So what is the horizontal asymptote, vertical asymptote? What's the x-intercept if we were to replace those numbers? Find the x. Okay, I think I said the answer by accident. And then number 4, write the equation of a rational function shown on the graph. Leave your answer in factored form. So this one here, you're given a graph. And then we write a possible rational equation, the equation for that. And then this one here, we try to give you some, or one application of this rational function. Okay? If you know somebody that you really want to work with, go ahead and work with that person. And it doesn't have to be 2 people, it could be 3 people. Okay? You can move things around. And yeah, just work at it. And the more you verbalize what you're thinking, the better it gets, the clearer it gets. Okay, so yeah, I'll be walking around, helping you out, and then towards the end of the class, maybe we can go over some stuff in here that, yeah, if you have any questions. Okay. Is there anybody who does not know anybody or is kind of too shy to approach people? Actually, you're too shy to approach people? Because I know some people already have a buddy, right? So, yeah. If you want me to pair you up with some people, then I will pair you up with some people.
Are we so
Yes, we are.